Children, now we are going to learn a small topic regarding pressure volume work or PV work or expansion work. So work done based upon pressure and volume. Before starting the experiment, we are going to see the signs of work. Signs of work. Consider a container filled with a gas and a piston is there. If the gas present in the container pushes up the piston, what happens? The gas get expand. So work is done by the gas or work is done by the system. In that case, W is having a negative value. Consider a container with a piston. If the work done on the piston, applying pressure on the piston, so what happens? The piston moves inside, so a compression takes place. So work is done on the system. Here by the system, here work is done on the system. In that case, W is having a positive value. This is work is done by the system having negative value. Here work is done on the system. So W is having, work is having a positive value. Now, so this we are going to see in an elaborate manner. Now, consider the container, piston filled with ideal gas. Now, the cross-sectional area of a cylinder, this one is A square centimeter. It's cross-sectional area. So, same the cross-sectional area for piston also A square centimeter, that we can take as capital A, cross-sectional area. Now, this volume of a gas, let it be Vi, that is initial volume, and pressure inside is Pi, that is P internal or P initial, also we can write. So pressure is Pi, volume is Vi. Now, if we move the piston inside, suppose this piston moves from here to here. So compression takes place. So this is the initial volume. Now this is the final volume, V final. That distance, this distance is considered as dx. Now, if we push the piston inside, compression happened. So what happens to volume and pressure? Volume also get decreased, is it not? Volume get decreased. So the pressure also changes from Pi to Pf, P final. So at this stage, in this stage, the external pressure and internal pressure are equal. So the distance is taken as dx. So the pressure and volume change. So internal energy also change. Energy here. So this is called pressure volume work. So for this work, W is equal to minus F force into dx. This is the first equation. Dx means distance travelled due to work. What is F? F means force. What is this negative sign indicates? This indicates since external force applied here, the piston, external force applied against internal pressure, internal force. This negative sign. So, this F force depends on piston and pressure. Piston and pressure. So force is equal to depends on piston, that is area of cross sectional A into pressure P. This is equation 2. Substitute equation 2 in equation 1. So W is equal to minus instead of F you are writing A into pressure, that is external pressure, into dx. So rearranging minus P pressure external into A into dx, that is minus pressure external into A into delta x, that is D means a small change, that can be written as A into delta x minus delta V. Delta V is Vf minus Vi, that is V final minus V initial. This delta indicates change. So strike out this both the negative sign. So P external into delta V. So W is equal to plus P external into delta V. If it is a positive value, already I taught, if it is a positive value, work is done on the system. This is so work done on the system. This is due to compression. This value we are getting. This is due to compression. This is work done on the system due to compression. Now if external pressure equal to internal pressure, that condition we have seen. Now suppose the external pressure is not equal to internal pressure. Now suppose external pressure, that is pressure external, if it is not equal to pressure internal, we have to integrate. So in compression always external pressure is greater than internal pressure. But in expansion, external pressure is always less than internal pressure. This you should not forget. In compression, external pressure greater than internal pressure. In expansion, external pressure less than internal pressure. So here also, now container, piston, the cross-sectional area A. Now the volume here changes from Vi to Vf. If it expands, so here pressure also Pi to Pf. So this is change in volume dV. So here if external pressure not equal to internal pressure, here you can write W work for the reversible process is equal to minus integral of, that is pressure internal to pressure final, pressure internal into dV. So upon integrating, we are getting pressure external is equal to pressure internal plus dP. dP if external pressure greater than internal pressure. Now external pressure equal to internal pressure minus dP, here plus dP, here minus dP if internal pressure greater than external pressure. Two conditions we are getting from the integrating. So, based upon this, pressure external, you can write as pressure internal plus or minus dP. From these two equations we are getting pressure external is equal to pressure internal plus or minus dP. So, W reversible equals to integral of pressure internal, pressure initial, pressure final, internal pressure into dV. So, for this P, take an ideal gas equation is equal to PV is equal to nRT. From this P is equal to nRT by V. Substitute it here. So, W reversible is equal to, here negative sign you have to write, minus integral of Pi to Pf nRT by V, P value, this is ideal gas equation, into dV. Here nRT is a constant value, take it out. So, W reversible is equal to minus nR, this is a constant, so we cannot integrate, Pi Pf dV by V, that is equal to minus nRT Vf by Vi. Now applying log minus nRT 2.303 log Vf by Vi. So, W reversible is equal to minus nRT 2.303 log Vf by Vi. So, now drawing a graph, pressure volume graph. Pressure take in the y axis, volume take in the x axis, and we are getting a linear curve like this. The work done is shown under the graph. This is the work done. Now I will give an example for this to calculate how to calculate the work done. Consider pressure volume. Now pressure is 2 decimeter. Consider. Now how will you calculate the work? The area under the cube is given as magnitude of work. So how will you find the work? So this is the graph you got. Now the area under this one is taken as work. This is the value 1. Consider this is 4. So V final minus V initial, 4 minus. So the formula area is equal to volume into pressure, 4 minus 1 into, here pressure is 2, 4 minus 1 is 3, 3 2s are 6. So 6 atmosphere per liter. This is the pressure into change in volume. This is the formula for area. So we are getting the value 6. This is how we have to calculate the work done. So if V final, if it is greater than V initial, that is expansion, work is done by the process. If Vf less than V1, that is compression, work is done on the process. So by this conclusion, If heat is absorbed by the system, it is the sign is plus Q. If heat is evolved by the system means minus Q. Work is done by the system means minus W. Work is done on the system means the value is, the sign is plus W. So this is very important, children. It is given in your book in page number 193 and 194. Shortly I have given this derivation also. You can go through this derivation and whatever points I taught, carefully watch the video and you can write in the note, or otherwise you mark it in the book. What I have explained, what is internal pressure, external pressure, how pressure applied on the piston, what is expansion, what is compression. So during compression what happened, volume get decreased, expanding volume get increased, such a way explained everything clearly. Then here how the work done using the graph. I have shown an example also. You go through the video and you write in the note at once. Otherwise, you mark it in the book. Don't forget, children.